Welcome to my channel. Mysterious and bottomless, the thousands of stars in the sky have captivated people since the beginning. Curiosity has always driven humans to discover new frontiers. We explored beyond Earth after thirsting for knowledge and technological progress. This piqued scientists' curiosity, and soon, new space travelers left Earth to explore the solar system without emotions or senses of either doubt or fear. For these scouts of the universe were machines. Cosmo, the first in outer space, roughly half a year before this video was posted on the 15th of April 2021, the automatic space probe New Horizons became the fifth spacecraft in human history to go beyond 50 astronomical units from the Sun. Pioneer 10 and Pioneer 11 were the first to do so. Some are active on their missions, while others are gone forever. Spacecraft New Horizons, start of mission, January 19, 2006. Distance to Earth, 52 Australian dollars 3 astronomical units per year, 14 kilometers per second. Main goal: Pluto and Charon's mission is complete. New Horizons performed a gravity assist maneuver near Jupiter before heading to its target. Like most interplanetary space probes, it greatly increased the spacecraft's speed and allowed it. The probe's cameras captured the first video of an erupting volcano on Jupiter's satellite Io to capture high-quality images of the largest planet in the solar system and its satellites. After the gravity boost, the probe headed for Pluto. The spacecraft reached the planetoids in January 2015. The mission's main objective was to photograph and map Pluto and Saturn from different angles. Moreover, the probe estimated magnetic field values, solar wind activity, and atmospheric and surface reflection properties near the objects. The program also searched for Pluto's undiscovered satellites and improved orbital parameters. After completing the main mission, the probe explored the Kuiper belt after leaving Pluto's orbit. Thanks to the probe's cameras, Kawa R1 and Darikoth were photographed. The Proxima Centauri and Wolf 359 distances were measured. Unfortunately, the spacecraft's radioisotope generator will run low in 2026, and all the meters will turn off. New Horizons will expand beyond the solar system. By 2038, the probe will be 100 astronomical units from the Sun. The spacecraft's energy generator will have stopped working by then, making communication impossible. New Horizons will leave our system forever after a hyperbolic orbit. Both Pioneer 10 and 11 probes experienced the same. Their escape trajectory from the solar system was the first automatic space probe sent into interstellar space by humans. Spacecraft Pioneer 10 mission begin March 3, 1972. Distance to Earth, 127 Australian dollars. Speed, about 12 kilometers per second, or 2 Australian dollars and 50 cents per year. Main aim: Jupiter. Successfully completed mission. Condition: inoperative. The spacecraft reached Jupiter's system on December 4, 1973. Space journey of 641 days. Images of the gas giant's surface and largest satellites were sent to Earth, and its atmospheric composition and magnetic field were measured. Jupiter also emits 2.5 times more thermal energy than it receives from the Sun. The unique data helped explain gas giants and their satellites. Pioneer 11, the second probe, passed Jupiter too, but its main target was the other gas. Saturn, our planet's giant. The probe's scientific instruments measured the planet's magnetic field, and its cameras took many photos of the gas giant, its rings, and Titan and Mimos, two of its satellites. The estimated distance between Pioneer 11 and our system's center is 106 astronomical units. After completing their main missions, both probes moved away from the Sun. Unfortunately, they're both out range since 2003, when Pioneer 10 last signaled. The last Pioneer 11 signal was in 1995. According to reports, both are rapidly moving beyond the solar system's boundaries and will never catch up with the two probes we'll discuss next. The Pioneers launched earlier. Voyager 1 began its mission on September 5, 1977, at 154 astronomical units and 17 kilometers per second, or 3.6 miles per hour. Astronomical units per year. Main goals: Saturn and Jupiter mission. Completed. Condition: non-functional. The importance of Voyager 1 to solar system exploration cannot be overstated. This probe discovered several new Jupiter satellites and its ring system, which was big news. The Voyager's cameras captured Jupiter volcano eruptions and proved Jupiter's Great Red Spot is a massive storm. The probe sent hundreds of photos. The largest planet in our solar system, and its satellites. The spacecraft's meters returned a lot of useful interstellar plasma data after crossing Neptune's orbit. Voyager 1 left the Kuiper Belt and heliopause long ago and is now rapidly crossing the solar system's scattered disk to reach the hypothetical Oort cloud's inner boundary. Voyager 1, the fastest and farthest spacecraft, allowed scientists to study the heliopause, where solar wind pressure and interstellar gas pressure balance due to charged particles colliding with rarefied plasma. Elementary particles and magnetic fields form complex structures. Studying them is essential for understanding cosmic processes, but by 2025, the probe's radioisotope thermoelectric generators will have exhausted their power in 300 years, cutting the connection. The hypothetical Oort cloud's inner boundary is expected to reach Voyager 1. The spacecraft will fly beyond the solar system after 30,000 years of cleaning through. The probe will pass Gliese 445 at 110,000 years later. 6 light years, then it will vanish into space. On August 20, 1977, Voyager 1's twin launched from Earth. Voyager 2 targeted Saturn, Uranus, and Neptune and approached Jupiter for gravity. This probe's images allowed scientists to assume Ganymede and Europa have subsurface oceans after reaching Saturn. Voyager 2 found new satellites and measured the gas giant's magnetic field and temperature. Lots of photos were taken of Saturn's surface and rings. The probe then headed to Uranus and Neptune. The flyby produced many unique images and revealed 17 of the 2-planet satellites. Ring systems were found on Uranus and Neptune. Neptune's gravity caused the spacecraft to leave the ecliptic plane. This prevented Voyager 2 from approaching the other objects, the solar system, but it had other exciting prospects. The probe was to measure star distances, survey the heliosphere, and gather valuable data on interstellar plasma and cosmic wind. The probe is 128 astronomical units from the center of our system, growing by 15.37 kilometers per second. It will take 42,000 years to reach Ross 248, a dim red dwarf in Andromeda. Since its launch 300,000 years ago, Voyager 2 will be 1.7 light years from the star. It may fly by Sirius at 4.3 light years. Unfortunately, such a tiny object cannot be distinguished from the Earth from that far away. Space exploration is just beginning, and interplanetary space probes are our first tentative steps. The infinite universe, they may be smashed on collision with the celestial body or recaptured by our distant descendants who will have advanced interstellar travel technologies to catch up with the probes. They may recover them from space and put them on display in a museum, but it is more likely that the fragile apparatuses will drift on for years and years through the lifeless.